Let's now continue our discussion of risk assessment with part 2 of our discussion. Remember, in our last discussion, we looked at continuous probability distributions, and we discussed a bit about the impracticality of continuous probability distributions. Insurance and risk management professionals commonly divide outcomes into a number of ranges or bins in order to use continuous probabilities to make practical loss estimates. But there's another set of measures insurance professionals commonly use to make risk assessments. Probability distributions can be used to determine central tendency. This is the best guess of what outcomes will be. In other words, it's an estimate. Let's look at the different central tendency measures. They are expected value, mean, median and cumulative probabilities, and modes. Let's start with expected value. The expected value is the weighted average of all possible outcomes. The weights are actually the probabilities. Think of our previous example. We multiplied each historical outcome by the probability that we calculated using the historical data. The problem with the example is that it doesn't have severities, so it's not terribly useful for calculating expected loss. An actual expected value, however, cannot be calculated with a continuous distribution because there's an endless number of possible outcomes. So we turn to the mean. You can only use a mean with empirical distributions as opposed to theoretical distributions. It is the average. For example, the losses per year divided by the number of years, and it is derived from actual experience. So the mean provides us in the insurance and risk management profession with an excellent tool for estimating expected values. Then there's the median and cumulative probabilities. These are also important. To calculate the median, line up all of the outcomes from smallest to largest. The one outcome in the middle, or a number between the middle two, is the median. So for example, if I have 17 observations, the 9th observation is my median because there are 8 numbers below it and 8 numbers above it. The median also has a cumulative probability of 50%. So it's right in the middle, where 50% of the observations are above and 50% are below. Medians and cumulative probabilities can be useful with bands of historical losses, as we discussed above. Also, we use cumulative probabilities and the median in an example in Excel that you'll find in Moodle. You need to study this example before you take the next quiz. Now let's discuss the mode. The mode is the most frequently occurring observed outcome. It's the one that occurs the most often. It's also the peak in a skewed probability distribution curve because it is the highest frequency, and the y-axis on a probability distribution curve is the frequency or probability. Let's look at some distribution curves now. These from your textbook are typical shapes of symmetrical and skewed or asymmetrical distributions that show you the relative locations of the mean, median, and the mode. The first two, figure A and B, are symmetrical. Figure A is a pretty typical normal distribution. Notice that the mean, median, and mode are all right in the center, and the mean, median, and mode are all equal. And it's symmetrical on either side of the mean, median, and mode. The two sides are mirror images. Notice that the outcomes are clustered around the mean. I could draw it even more clustered around the mean, like that. These are more predictable outcomes, and in figure B, you have less predictable outcomes because they're scattered further away from the mean. The outcomes in figure B are not as closely clustered around the mean. Now let's look at figures C and D, those distributions that are asymmetrical. One is skewed to the left and the other is skewed to the right. When we say skewed to the left, it's because the mean is to the left of the mode. That's how you know. This occurs because of a low outlier. So while the most commonly occurring outcome, which has the highest frequency, is the mode, is to the far right, the median is to the left. So this is where 50% of the outcomes are above and 50% are below. But the mean is even lower because of a low outlier that's drawing down the average or mean. Conversely, you see in figure D a positively skewed distribution where the mode is lower than the mean and the median is in between the two, 50% higher and 50% lower. But the most commonly occurring outcome is lower, and a high outlier is pulling the average higher or to the right. These are also known as tail to the left and a tail to the right. The tail is here and here. Now let's talk about using dispersion. Dispersion is the extent to which the probability distribution is spread out, as we just saw in the distribution curves we looked at. Less dispersion equals less uncertainty. Just as I pointed out, a normal curve like this is more dispersed than a normal curve like that. This normal curve is more uncertain. Two widely used measures of dispersion are the standard deviation and the coefficient of variation, which are actually closely related. The standard deviation in a normal bell curve is very useful because within plus or minus one calculated standard deviation of the mean, you have 68.26% of the observations. And within two standard deviations of the mean, you have 95.44% of observations. And 99.7% of observations fall within plus or minus 3 standard deviations of the mean. Most distributions of actual outcomes aren't quite this simple, but many times insurance professionals assume a normal distribution for practicality. The coefficient of variation is closely related to the standard deviation. It is actually the relative standard deviation, and we discussed it briefly in Principles of Risk in Insurance. It's simply the standard deviation divided by the mean, and it makes two completely different observations more comparable. A large standard deviation with a very large average may be less risky than a smaller standard deviation with a smaller average. In addition to using loss distribution curves in order to analyze losses and predict future outcomes, risk and insurance professionals can also analyze loss exposures in a simpler way, simply by using loss frequency and severity. The Prouty approach is similar to the frequency and severity table I show in Principles of Risk Management and Insurance, but it takes that table and expands it into more quadrants. As you can see, you have loss severity and loss frequency as the main elements of the table. And you have several categories of each: severe severity, significant severity, and just slight severity. And then in terms of frequency or probability, you have almost nil, slight, moderate, and definite, meaning it is absolute that it will occur or certain. And within each combination of frequency and severity, you have the different treatment methods. So, for example, if the frequency is almost nil and the severity is severe, you would reduce or prevent or transfer. If the frequency is slight, again, reduce or prevent or transfer. If it's moderate, you reduce or prevent and retain, because this type of loss happens often. So you try to reduce and prevent it, but you retain it, because transferring it, for example, to the insurance company would just be trading dollars with the insurance company. Your premium would be much too high. But if the chance of loss is definite, in other words, it's a certainty, and the severity of loss is severe, you would avoid it. The treatment methods actually don't change when the severity is significant, but when the severity is just slight, at that point, there's no point in transferring the risk. In each quadrant here, you see retain. That's the end of our discussion of risk assessment. However, you will also need to watch the video that shows the use of cumulative probabilities in Excel. You'll need to study that for quiz 6.